Welcome back, everyone. This is Blue Dolphin with the Hoplite Security Channel. Today, we're going to be covering the Hack the Box Pandora machine. It was an awesome machine, but I felt like it was pretty difficult for an easy machine. So did the community. Let's get into it. Welcome back, everyone. This is today to cover another Hack the Box machine. Today, we're going to be dealing with the Pandora machine, an easy rated machine. Starting from the top, a high-level summary, there's going to be a focus on enumeration with uncovering a UDP port and an SNMP service. We're also going to have to find an internal website with an SQL injection vulnerability, do some admin session hijacking, little persistence, and path injection. Alright, well, what does the enumeration phase look like? Just the two standard ports, 22 and 80, with 166 to be uncovered later. And remember, we have to focus on the SNMP service and even enumerating for the internal website later. Alright, the initial foothold looks like a hidden UDP port on 161, and we find credentials after doing some SNMP service enumeration as user Daniel. We're able to SSH in where we do an internal web app discovery. We port forward so we can access that web application where we find an SQL injection, CVE, that allows us to find cookies to perform session hijacking. Pivoting over to the privilege escalation portion, we land a shell that we have to jailbreak out of due to application permissions. Then we do a SUID discovery with some path injection to root. So without further ado, let's get into it. We're going to be getting into phase one of this engagement where I'm going to be showing the enumeration portion of this, which was to just find the two standard ports, port 22 and port 80, and then uncover that hidden port. So this will be a fairly quick phase. Starting from the top, as usual, we're going to run nmap on our target, nmap 10.129.98.52. And while this is running, I have auto recon already queued up to run in the background, just because it does take a while to finish doing its job. We can see our results are fairly standard here, just the website and port 22. So we'll go ahead and take a quick look at the website, where initially when I was looking at this, it became fairly clear that there wasn't a whole lot going on and I had to look elsewhere. We have a website that loads this play extension of panda.htb, bringing network monitoring solutions to your doorstep. So this is kind of a hint at what's going on here. Network monitoring solutions, well, there's the protocol SNMP, the Simple Network Management Protocol, and this is kind of hinting at that. And we can look through here, and there isn't a whole lot going on here in terms of anything interactive that we can possibly play around with. Looking through the options on the website doesn't reveal a whole lot. Same with doing directory brute forcing or inspecting the website across content, network traffic, cookies, nothing here. There is this little send us a message app, which I played around with and I got nowhere. Jumping back over to auto recon. Eventually, I learned about another port, the UDP 161 port, and we'll find this in the report directory here. My apologies, in the scans directory. And you can see here we have TCP 22, TCP 80, and a UDP 161. And let me just make my text a little bigger here. Jumping into UDP 161, we can see that we have several SNMP scans that have been run against it because it's been identified as an SNMP service. Now, we could look through all this one at a time, which is fine. However, we're going to just manually do this for the purposes of demonstration, and you can use the tool SNMP walk, I believe, against the target. And it says no security name specified. So what this means is we need something. We have to pass something to the target in order to enumerate it. Well, what exactly do we pass? Well, it's known as a community string. Before we jump into that, let me just queue up a more in-depth target scan against this target over at port 161. And of course, it needs root privileges. And what we're looking for, going back to the SNMP service, is the community string. And the community string is kind of an identifier that says, hey, this is what you need in order for me to provide you with the information for the network management protocol. Whoops, my mistake. Let me run that nmap scan again here. And you can see we have our port 161 UDP SNMP service, and it is SNMP version 1, but it has a net SNMP version 3 server, and then this public in brackets. Now, I'm not sure if this is intentionally there to denote the community string. And just on a side note, how the community string works is by default, it's public. A lot of vendors just have the community string as public. So if you have multiple devices on a network, vendor A might have all their devices only respond to an SNMP request. If the community string says, I don't know, vendor name, or perhaps vendor B, they're going to have a community string that's something silly like trees in the forest, and services or devices are only going to respond if that community string is presented. So what we can do from here is we can try an SNMP walk against our target. The way we'll do that is, as we saw earlier, SNMP walk, and we'll just do -H for help. And we have to specify a community string here, I believe. And we're going to be looking for, we're also going to need to try different versions, because we saw that we have version 1, but then a version 3 server. I'm not really sure what that means or how that works. So we're going to try them all, but then we also need to specify our community string, which is lowercase c. So we'll try that. We'll go lowercase c, public, our target 10.129.98.52, and then version, how did we do the version? -v1 or 2c or 3. So we'll go v1. And then if this works, we'll output this in v1.text. Permissions denied. Oh, let's get out of this directory. That's not a good place to be. And we'll try this again. And then just while this is running, let's take a look to make sure it did in fact work by browsing to that location and just looking at that file. So we'll cat v1 text, and it's definitely working here. Perfect. Now let's go ahead and queue up the other commands, or sorry, the other version. So we'll do SNMP walk -c for public, and -v, we'll do, what was it, 2c for version 2. I don't think there's a space. Our target, and we'll output this to v2.text. And then we'll go ahead and do this for, I think just v1 and v2 will be enough. Taking a look at those files here, we're going to do cat v1.text. A lot of information there, so if we just check the header, we can see that in the file here we have our OIDs, which are the identifiers. So on a side note, when a vendor has a product that uses the SNMP protocol, they'll have a MIB file which says, hey, these are the OIDs that our product's using. But we can see here that we have a name Daniel, Pandora, Mississippi, a number 72. So we're going to look through this file a little more and just check for anything to do with the word password. We find nothing. Cred for credential, nothing. User, nothing. We'll look for Daniel, lowercase. Oh, the issue there was I was running head every single time. My apologies. Let's change that to a cat here. And you can see we're still finding nothing. Checking for password. Checking for Daniel. And here we have a string, an OID with credentials inside of it. And you can see we have Daniel and Hotel Babylon. So that concludes phase 1 here, which was just, again, an enumeration phase where we found 2 ports, 22 and 80. And you had to really dive deep to find that hidden UDP 161 port, which was an SNMP service, and a little enumeration with SNMP walk provided us the information with credentials that were found in the OID. And other than that, that's a wrap. We're going to be jumping into phase 2 next of this engagement. Welcome back, everyone, to phase 2 of this engagement, where we're going to be connecting to this machine as user Daniel, doing some internal enumeration where we find another website. We're then going to use SSH port forwarding so we can view that website, and we're going to research and find a CVE attributed to the web application. Without further ado, let's go ahead and connect to our target as SSH Daniel at 10.129.98.52. Being prompted for our password, Hotel Babylon 23. So once we're in, the first thing we'll notice is there's two users, Daniel and Matt. There is no user flag here either, but in Matt's directory, there is. I'm trying to output the content, doesn't work, permissions denied. Looking around more, we'll check the var www folder, where we can see that there's two directories here. And this is suggesting that maybe there's two websites. One of the ways we can confirm this, we can clearly see the Pandora has a Pandora console directory and is going to be more robust than whatever that HTML directory is. But the next thing we can do is actually just check etc patchy 2 sites enabled. You can see here we have a whole range of files hosting the Pandora website. So let's go ahead and check etc patchy 2. Sites available or enabled? I think it's, we'll check both. Yeah, so here we have default.conf and pandora.conf. And then let's check sites enabled. Does that not exist? I might be making that up. Oh, I'm still in sites available. So in sites enabled, we will also see two directories for two possible different websites. So we can also check our ports by doing netstat-tulpn. And here we see we have port 80, but we don't have anything else that we think could be running a website, but we do see port 3306 on the local host. So that's a MySQL or SQL port, which is suggestive that we're dealing with possibly a web application that is using a database in the backend. This is key. We could target that SQL database, but first we want to finish confirming if we have a second website. From here, we'll check etc hosts. And we can see that we do indeed have multiple host names. We have localhost.localdomain, pandora.htb, and pandora.pandora.htb, which are set for 127.0.0.1, and Pandora is on 127.0.1.1. We're not going to be able to view these unless we view them from our target machine, which we're currently connected to as user Daniel. So what we're going to have to do is actually port forward this. The way we'll do that is SSH-listen on port 80, localhost forwarding port 80 as Daniel, and our target 10.129.98.52. And if this works, this will forward our port. We'll enter the password, and then we'll use netstat to see if it's indeed working. We don't need auto recon anymore, so we can do netstat-tulpn. And it appears it is working. You can see we have the local address listening over TCP on port 80 here with an SSH PID. Wonderful. What we'll do from here is take a look to confirm it worked. By browsing to 10.129.98.52. Whoops, my apologies. 127.0.0.1 over port 80. We can see here that we do indeed have access to this new host that we've port forwarded. This is wonderful. The first thing we notice on this page is there's really nothing here for us other than a login page. However, looking down at the bottom, we see this version number. This does look like a unique identifier, so running this across the internet reveals several CVEs for what we're dealing with. So it looks like we're dealing with Pandora FMS. Let's quickly look that up, Pandora FMS. And this is a software for monitoring computer networks. Just like we learned on the initial page, we're dealing with computer network monitoring software. Now we're looking for a CVE in it, and we have a version. We know that there are several CVEs available here the more we look into it. Now there's several CVEs we could look through. However, we're going to be jumping into that in the next phase, where I'm just going to demonstrate the CVE and how we get escalated access to the target. But this concludes phase 2, where again, we just talked about gaining access with our newly found credentials to the target, doing some internal enumeration, finding signs of a second website, really digging around to confirm those findings, and then gaining access to that website, which was done by forwarding the port which it was sitting on. It was port 80, and we now have access to this new web page, which is indeed Pandora FMS, which is indeed using the SQL database to store all the information. I'll see everyone in phase 3 of this engagement. Welcome back, everyone. This is going to be phase 3 of this engagement. This is going to be a large portion of the engagement where we're going to be locating the correct CVE here, exploiting it, ultimately dumping a table of session cookies, trying them to get access as an elevated user, and then finding a already crafted payload that gets us the admin session cookie, and using that admin session cookie to access the website with a logged in session, where we then find a file management option under the admin tools that allows for malicious file upload, which ultimately gives us our reverse shell. So getting started here, I initially noticed that there were several CVEs. This one, for example, was to do with index.php, and it just allows an upload malicious PHP script, which is interesting, but this isn't helpful because we're not logged into the device, so we're not going to be able to do that. We take another look at what shell.systems is offering here, and this is something to do with the net flow. This is to do with a command being passed to a get, and this isn't what we're going to be dealing with here. I did look through this, but this was kind of a red herring in many ways. And we can see there are several CVEs. So what we'll do is we'll actually take a look at all the CVEs here before we start diving into one in particular, because we do have several. So what we'll do is we'll type Pandora FMS CVE or CVEs. Taking a look at Pandora FMS, looks like they kind of have this all prepped for us on their webpage. This is nice. You can see that we do indeed have many listed CVEs. And the one we're looking for in particular is this one here, an SQL injection vulnerability in the Pandora console component of a trick of Pandora allows an authenticated or non-authenticated attacker to upgrade their privileged session via the include chart generator.php session ID parameter, leading to a login bypass. Well, is this applicable to us? The way to tell is for us to just copy and paste this directory. So let's see if it even exists. And I think this would go on top of the Pandora console. And you can see access not granted. So indeed, we do have access to this, and we can dive into the CVE a little more. So opening this up, we see that we have a session ID parameter that leads to a login bypass. So what we'll do here is we'll add a session ID, and we'll just say query session underscore ID equals A, and it does accept this. You can enter some quotes to see what, oh, and here you go. So here we have a quote-based error enumeration, and this says you have an error in your SQL syntax because it was, of course, a quote, single quote. We're asked to check the manual that corresponds to our MariaDB server version for the right syntax to use. And you can see here that we have leaked information on the backend query to do with tsessions underscore PHP or ID session in this location online 114. So this is very interesting. What we're going to do is dive into this a little more by copying the CVE and just looking around online to learn a little more about this. And perhaps we can find out what type of SQL statements we're looking for here. So it looks like we do have this POC on GitHub. We'll take a look at the detail blog. We just learned a little about Pandora FMS, which we already know. The impacts here, SQL injection pre-authentication, which is definitely what we're looking for. The technical analysis, we don't want to dive into this too much. But you can see the include chart generator.php, which they've referred to, is the vulnerable area here. There's no sanitization when input is being passed to the session ID, which falls under the constructor of the class Pandora FMS user. So then the check login is used to check if a login session variable is set and valid. The function check login evaluates true if a user with the given session ID exists. So this is how we can kind of conduct a session hijacking attack, is by finding a session, inputting it, and then we're just simply going to get that user session. There's going to be no other sanitization or checks and balances on the way. And the way to get that session ID is going to be through SQL injection. So what we'll start to do here is we want to figure out what type of SQL injection it's available or vulnerable to. And the way to do that is going to be to use Burp Suite for one, to capture our request to the server, and we'll save this and run SQL map against it. You can see here I have my Burp Suite session, my proxied session, so I'm going to run this. We're going to capture this request. However, the issue here is that we don't have a cookie. We need our session ID for this to work. So if we forward this, let's take a look at the response and do a quick page refresh. Whoops, I think I opened up a copy there of the browser. There we go. So let's rerun this. And now we have our cookie, which has been assigned to us. So from here, we can go ahead and save this item. And we'll save this as request. We'll just call it request. We won't need Burp Suite anymore, so we'll close that. We'll simply run SQL map -r against our request. I think I'm missing something else, but let's just try this. And we're going to accept the defaults here, so we're going to use, we're going to not use our so-called tainted parameter, so it ends. Well, let's just try it anyways with our tainted parameter and see what happens. So it does say that there's a potential permission problem. Well, okay, so we have to run sudo. Silly me, I should have known that. And you can see we get the tainted parameter variable again. So let's just let it run to see what happens. It says the backend DBMS is my SQL, and we did indeed receive an error, but we did have several successful payloads in a sense, or it's suggesting that right here where we have session ID, this and this. So what we'll do here is we see the MySQL comment. This is interesting, payload session. So yes, we did ID equals, commented out, did a quote, and or if equals this. That's very interesting. So what we'll do to kind of work on this is we're going to run SQL map again. However, we're going to go after the database in this case, which having actually just occurred to me, we need to know the database. So the way we're going to do this is by running the dump command right after we run our, let me just check, let's do SQL map -h for help, and --dump dumps the DBMS database table entries. Okay, so let's do --dump and see if this works. Yes, we'll use our tainted parameter. We'll take the default option, and we can see here that we have a partial value Pandora. So it's saying resuming partial value Pandora, fetching columns for table event rule in database Pandora. So now we know the database, and now we want to know what tables are available in this database. And we're being asked about the columns. We can run this, and we definitely confirm that we have Pandora as our database. While running that, it actually proceeded to output the tables of the Pandora database, which is awesome. We didn't have to do that. And it's dumped the tsessions_php table. So this is very interesting. Something we notice here is this cookie session ID for user Matt. Well, we already know that user Matt was indeed on the box earlier. Now we could try and copy his session, which we will, to see if we can actually gain access as him, provided he does have a valid session. So we'll go 127.0.0.1 over port 80. It brings us here. We'll take a peek at our cookie and swap it out by just literally copying, pasting, and hitting refresh. And this is great. We have access as Matt. And this is good. However, Matt isn't an administrator. So we can only get so far, and I wasn't able to do anything from within the system to kind of elevate my privileges, other than to learn Matt was not an administrator. Now, if you did manage to do anything in the back end here as user Matt, I would love to know. Please comment down below and let us know. But what we're going to have to instead do is leave this session as Matt. So we'll just log out. Not that it really matters. But we need to get access as an administrator. And you can see in this table, there's simply no administrators. But perhaps one of these sessions is an administrator. Well, there's a lot of sessions here. So we could use wfuzz to see which one's working. And that's definitely a possibility. However, there are POC custom crafted SQL payloads that actually fetch admin from the table, and we'll take a look at that. But we're just taking a look at the table T per fill, which SQL map output. You can just see we have something called the Pandora administrator here and some operators. Continuing to look through their information, there is a ton more of information that's being output. We continue to go through here. We see we have the T session table. So this is interesting. We have our tables, and you can see we do indeed have admin here, and this is great. We have a user admin that has logged on. Unfortunately, these timestamps are off, so this isn't very helpful, but we can see that there is a profile added for user Daniel, and there was a account created for Matt. There's an updated user admin change. This is interesting. So we really want to get access if possible to one of those sessions, but let's keep scrolling through, and we'll continue to let SQL map run. And just looking again through the Tesario table, which was dumped, you can see here that the identifier for is admin for Matt, Daniel, and Matt is all set to 0. So none of them are going to be administrators, but one of these tables somewhere is of course an administrator. So what ended up happening here is and I don't know if this was the intentional way or not. However, I just found a vulnerability, which let me go back on GitHub. I think we just looked at it earlier. Right here. This POC here is actually designed to get us the admin cookie. So if we jump over to CyberChef here and take a look, because it is URL encoded, and there's a cat on the back of my chair, just FYI in case you're wondering what that is. But we do URL decode. You can see here we have our payload, which is the Pandora console that we already know about, the include chart generator, yes, we know about that, the session ID, yep, we're well aware, but it looks like it's a union select vulnerability, and what's happening is it's looking for ID usuario, so our table is in Spanish, and it's looking for S5, which is the permission identification of admin, as data from TS sessions PHP. Now, we did have a look at TS sessions, so let's actually just scroll up and take a quick look at that again. So what's interesting is I'm looking at T sessions underscore PHP, and there is definitely nothing that has the admin identifier of 5. It's either null or 6. So I'm not sure why this worked, but if you know, please comment down below. And what we'll do is we're just going to copy this payload, pass it to the site. We're going to inspect the page, look at the cookie, and you can see we have this cookie here, NEP, and I'm just checking on our T sessions table, and I don't see it for ID sessions. I'm not sure why that is if we dumped the table, but I'd sure like to know. What we'll do is we'll copy this session to confirm if it works or not. Jump back over to our initial login page attempt. The Pandora console, of course, and we're going to input this session cookie. Refresh the page, and we're now in the backend, and we have access to the admin tools, where looking in here, we see a file manager. And we have the option to upload a file. So what we're going to do is just create a PHP reverse shell file. I always like to use the long version. I'm not a fan of the short version. So I'm going to copy this. Create a shell.php file, paste this in, scroll up to the top, substitute our information, which will simply be the IP address, and our port, which I'll do my favorite port, 6363. And now we'll create a listener, netcat-nlvp 6363. We'll upload this web shell. Pandora, shell.php. We have to figure out where the file's being uploaded to it, and it says index of images, so in this case, the first place you check is just images. And sure enough, everything's there, which was nice. Sometimes it can be a pain to figure out where files are being stored. We'll scroll down to the bottom for shell.php, where we see it here. We click it, we have access. Who am I? User Matt. So that concludes phase 3 of this engagement, where, just again to recap from the top, we started off by identifying the version of our Pandora FMS where we learned about a vulnerability to do with SQL injection. We were able to use Burp Suite to capture that request and do some table enumeration, where we did find those session cookies, but we couldn't find the admin session cookie for some reason. However, there was a union select SQL payload as a proof of concept out there that did in fact get us that administrative session, so we could get the cookie. With that, we were able to swap out our cookies, gain access to the backend, take advantage of a file upload function where we were able to upload a PHP reverse shell, and we were able to get access. So that's a wrap for this phase. See everyone in phase 4 of this engagement. Welcome back everyone to phase 4 of this engagement, where we're going to be doing our final leap to root, and we're going to start off with using linpiece to help identify the system, where we're going to identify a SUID binary known as the Pandora backup. From here, we're going to realize we have some issues, research those issues, learn that there are some application permission restrictions since our shell does spawn from the parent process of the web application. So we have to escape this, and the way to do that is by doing an SSH connection into the box, where we have to play around with the permissions a bit. But once we're in there, we'll take a look at the Pandora backup, where we learn there is a path injection vulnerability, and we simply just put a reverse shell, not even a reverse shell, just a bash file, and we get access as root. So let's get started here. You can see that I'm in here as Matt, and our working directory is currently temp, and we're going to call the linpiece file, which I've just spun up on a previous tab here, hosting the file. You can see here with Python 3-m HTTP server. So we're going to call our script over at 10.10.14.7 port 8000-linpiece.sh, and then it worked, and now we're going to run linpiece.sh. Permission denied. Let's change permissions to all 7s, blast them away, never do that in the real world. Let's run linpiece. And it's running. This is good. It's got the color coding. First thing it shows us is that we're user Matt. We're in the Matt group. Our host name is Pandora, and the writable folder is dev shim, so that's great. Taking a look through the output here, we have our system output, which is helpful. There's then a CVE check, and we're being informed that it's vulnerable to a certain CVE, so naturally we're going to take a quick peek at that. And we learned that there's a privilege escalation vulnerability on the Polkit's PK exec part of a SUID root program. So this is interesting. Let's go ahead and take a look at this. So there's a binary somewhere here that's being used, and we can see that this is on all major Linux distributions. We want a little more information on this. All right, we could try this, and that's definitely possible. However, I initially looked at it and I got nowhere with it. But if you got it to work, please let me know. I'd love to know how you did that. Taking a look at the paths here, you can see we have our user, local sbin, pretty standard paths, nothing special, new paths exported. Nothing special in the environment. The Linux exploit suggester is making several suggestions, which I didn't find any of these to work. So one was for the POEM kit, one was for heap-based overflow. I don't even know what this one was. Oh yeah, this was a kernel. Then again, there's a set UID screen vulnerability. So I have seen set UID screens before in one hack the box machine, but again, it says less probable. I think these are all, so these are probable, these ones are less probable. Again, I look through these ones didn't really get anywhere. Continuing to look through here, there's several cron jobs that are running, quite interesting as well. Looking through these, I don't initially see anything. I do see our credentials that, of course, were used as user Daniel. Continuing to look through the output here. Again, nothing notable in cron jobs. System path, everything looks fine. Nothing under system timers. So we're now looking at the PK Exec Policy, which was interesting, because I know that was mentioned earlier, but nothing special there. No pseudo tokens. P-trace protection is enabled, however. Interesting, not sure what that's about. You can see that we do have the MySQL database being identified here, which is neat. There's some enumeration now of the database files. We continue to look through here, and there's nothing that really stands out other than those initial CVs that we found. The spacing's kind of getting weird here. Oh, SUID, what's this? So, okay, so under SUID, we can see that we have that PK exec that we saw earlier, but this is interesting. We have a user bin Pandora backup. So let's go ahead and take a look at that. That sounds pretty juicy. Let's copy over the mat shell, which we're in. First thing we want to do actually is upgrade our shell. So we're going to want to do a Python shell upgrade. So we're going to do the Python 3 call import PTY spawn bin bash. There we go. Now we're going to jump over to, where do we see that? It was in user bin, and then I believe it was from here Pandora underscore backup. So it tried to run, and it said it's trying to back up the Pandora FMS client, and it attempts to run tar, but it can't open. There's a permission issue. Error is not recoverable. Backup failed. Check your permissions. So let's take a look here at the permissions. And you can see that, yes, it does have the sticky bit, and we should be able to run it as mat. However, that's not happening. This is odd, but let's take a look at our listed sudo permissions with sudo -l. We get this very interesting error. And the way to determine what's going here is we're just going to copy it and take a look. We're copying this whole line, pasting it into Google, and let me actually get rid of some of these. Let me just do this set sudo operation not permitted. And we start to look through this, and we learn that there's various things that can kind of interfere with this. Someone here is saying an easy way to do this is to actually just run sudo-iu and username. And again, we have the same issue here. There's nothing much of why this is happening or what's going on. We continue to look through this, and I eventually came across this site here to do with ITK NPM, which is like a security feature. So if we take a look, I'm trying to find some official documentation, something that'll be a little nicer to read. This is just the official documentation, and this is what I eventually found after a ton of research, literally hours of research, is that the NPM ITIC for short is a multi-processing module for the Apache web server, which we have, and allows you to run each of your virtual hosts under a separate UID and GID. So this is another layer of security. And the scripts and configuration files for one vhost are not readable for the other, so they're totally separate. It's kind of like micro-segmentation of service jobs running. And it's non-threaded, which means you can run non-thread aware code like many PHP extensions without issues. On the other hand, there's a performance hit. This is ultimately what's going on here, is Apache is running our Pandora FMS system with the NPM ITIC, multi-processing module, and it's forcing that process to run as mat and only as mat. So that was where our shell is generated. So the way to get around this is simply by creating an SSH key. which did get a little tricky just because we'll have some issues, which you'll see here shortly with the permissions. The way we'll do this is we're going to go over to user Matt's folder, his SSH folder in particular. And he does not already have an SSH folder. We are able to cat the user.text flag as Matt. That's the good news. We'll make .ssh. Now what we're going to do is SSH Key Gen, and this will create our keys that we need. And what we'll do is we're going to copy his public key if that worked. Should have. Let's make sure it's a properly formatted key. Awesome. So we're going to copy this into the authorized key file. So we're going to go copy id_rsa.pub into authorized keys. And it looks like that did indeed work. We'll now copy his private key and just try to connect with it. We'll create a new tab here. Whoa, I don't know what I clicked, but did I lose my shell there? I think I did actually lose access as Matt, I think. What? Nope, looks like we're still there. Wonderful. Let's create that new tab and jump over to Pandora. We're going to do nano ID_RSA. Put our proper permissions on it, as always, which are going to be 600. Now we'll connect as user Matt, -identity, IDRSA, Matt at 10.129.98.52. It asked for his password, so this didn't work. Let's take a look at the permissions now. We know we have the correct permissions on our private key, but jumping over to Matt here, we need to take the permissions on the authorized key folder, for example. So the authorized keys right now is set to read, write, read, read. We want to change this to permissions 600. Oops, I spelled it wrong. Gmod 600, authorized keys. And we're going to take a look at the permissions again and see that we now have just read, write, which is good. The other issue here is that on the public key down below, actually, I think that's fine. I think this should work. No, it doesn't look like it worked. Let's try changing the permissions on the, I'm just thinking, I'm not sure. Let's take a look at the SSH folder. I see. So the SSH folder has too many permissions. So if we look at our SSH folder by default, for example, we'll never see those type of permissions. So if we jump into SSH and just look at the permissions, we'll see that our SSH folder does not have maximum permission. So we're going to want to change this to be safe. And I believe it's going to be permissions 600, but I might be wrong. Let's see if that worked. No, that didn't work. I think it has to be permissions.ssh folder permissions. I think it's different. I think it's view the permissions of your SSH directory, so it's world readable, which has to be 755. So let's try 755, gmod 755. Oh, wait a sec, that's not where I want to be. Change mod 755.ssh. Let's see if this works. There we go, it worked, awesome. So we are in here and we now have the upgraded shell. So from here, we're gonna take a look at the Pandora backup. Let's just take a quick look at our environment here. And so we can execute the Pandora binary because it's in user bin. But let's also take a look at our sudo-l because this should be working now. Oh, right, we don't have permissions as Matt. Okay, but we don't have that permissions issue where we were being kind of containerized from the npm itic the multiprocessing module. So what we're going to do is just try and run Pandora underscore backup. And it's doing a ton of information. That's too much. So let me just Control C that. Let's just take a look at the header. That was a little much. We can't, oh, can we do that, or are we too far gone? All right, so we can see here that Pandora FMS is a backup utility, and it's now attempting to back up the Pandora FMS client. So the first thing it's doing is it's calling tar. It's removing leading lines. It's removing leading lines from hard link targets. So it's interesting that it's calling the tar binary before it gets into www Pandora, because so it's just calling tar from the command line. So if we try that, yep, we can also call tar from the command line. So if we look at our environment variables, this is kind of suggestive. We could just put tar in the first place it's going to check, which is user local sbin. So I don't know, let's try it. Let's go user local. Let's go change directory actually, user local sbin. Let's see if tar exists here. There's literally nothing here. Great, so we'll go nano, tar, and we'll just say bash. Oh, permissions denied. Okay, so we just don't have permission there. All right, next one will be user local bin. I guess let's try user local bin. I'm just curious what the permissions do look like here. If I go back on sbin, oh yes, we don't have access at all. So let's take a look at user sbin, and we just want to figure out where we can put tar, because this is a path injection vulnerability. My apologies, just to explain, because we're seeing that tar is just being run from the command line in the Pandora underscore backup binary, and it shouldn't be. There should be a absolute path, not just a relative path. We need the full path name in order to be safe. So let's take a look at user local bin. Looks like we're here. Take a quick look at the permissions. Yeah, same thing. Okay, fair enough. Let's take a look at user sbin. Same thing again. All right, so we're not really getting anywhere, and we just might have to import our own environment variable. Yeah, we're not going to be able to create anything in here. There's no way. Nano, let's say Varda. No, okay. Let's go ahead and create our own environment variable. I'm just thinking here, I actually don't know if I need to create a custom variable, because we're just calling var. I wonder if I can just place that in the same directory that I run the Pandora backup from. So let's try here. If I just go like echo bash var, yeah. So let's try Pandora backup sudo Pandora backup. No, doesn't work. Okay. Actually, let me just change. I forgot about permissions, because let me at least just change permissions, change mod 777 var. I don't think this will work. No, because we're still a user math, so that doesn't work. Okay. Oh, you know what? Silly me. I have to actually do bin bash. So let's do bin bash. Double quotes bin bash. Replace var, cat var. I think. Oh, no, I did it. I don't want to append. We want to actually replace echo bin bash. Var, cat var, change permissions. I think they're already changed. Let's try this now. I don't think this is going to work though. Yeah, no. So we're still the user. All right, that's fine. Let's go ahead and make a custom environment variable. It just occurred to me that the dev shim folder we saw earlier when we were enumerating was writable. So I'm just thinking, what if we do echo bin bash var thinking this will maybe have a better chance of working. Nope. We're still the same user. All right, that's fine. All right, let's go echo. Let's go back to the temp folder. I guess we could stay here. What does it matter? Let's just try. Let's go echo path just to confirm what we have. All right, fair enough. We'll go export path equals temp and add it to this path. Now when we go echo path, whoops, echo variable path, you can see we have temp. Okay, so sweet, let's run Pandora underscore backup. I think this will work. Nope, okay, maybe we do have to use dev shim. Let's go dev shim. Let's go export path equals dev shim variable path. Now when we look at our path, we should see our, yep, dev shim. We have the var file here. It's got the permissions. Let's try this. Pandora backup. Whoops, didn't spell it right. Pandora backup. Still not working. Let me try this again. Let's go nano var. Let me just do bash. Super simple. Yeah, change mod. And we'll run Pandora backup again. Interesting. All right. Actually, not too sure what. Well, wait a sec. I'm. Oh my goodness, I'm so backwards here. Sorry, everyone. I'm actually using var instead of tar. I totally have it backwards here. Yeah. No, I'm totally wrong here. All right, let's kill var and let's go echo bash tar. Oh my goodness. All right, tar. And now we'll go change mod. And we'll run the Pandora backup utility. Oh, and there we go. We are root. Okay, perfect. So I just had it backwards. Anyways, that wraps up this part of the engagement. So again, just to conclude for phase 4 here, we first upgraded our shell to a Python shell. We identified a SUID binary, but we didn't have access because there was some application security kind of containerizing. So we had to escape out of that by creating an SSH key, changing the permissions because they were excessive on Matt's SSH folder. We then had to look at the binary and just realize it was calling var right from the command line. So we just created a environment variable to cause path injection with literally a file called var that just ran bash, and that gave us access as root. And that's a wrap. Other than that, like, comment, subscribe. If you did this differently, or you have any feedback, suggestion, or comments, please comment down below. If there's anything we can do to improve in the content we bring to you, please